Okay, good afternoon. Welcome to IPv6 working group. Here on the screen you can see Bob, who could not be with us in person today. He prefers to be in Hawaii, doing some sailing stuff. I think it's a good hint where the next summer IETF should be next time, all right? Okay, here is our IPv6 mascot, and I'm Jen. So, note well, please take a look at this. I am not going to read it to you because you should not suffer for too long from my accent. So slides are available. Please read it if you are not familiar with the content. So basically, what Note Well was saying is that you already agree to follow IETF guidelines when you register, and we expect you to behave professional, be nice to each other, even if you disagree technically with what's being said. Some useful tips. First of all, if you are not on Meet Echo already, please scan the QR code, which used to be on that screen. You can find in the entrance on the room, or you can just go to the agenda, find the on-site tool and use it. First of all, you're going to need this if you join in the microphone queue. And secondly, I suspect that microphone might be turning off. Thank you. Yes, as Tim pointed out, QR code is actually available on the microphone. So if you don't know where to find the QR code, it's there. And when you join the microphone queue, please use the on-site tool and join the queue. It would help drastically so chairs could manage the queue. And secondly, the QR code scanning is actually replaced blue sheets for those who remember those things. People who are remote, please keep your microphone and audio, video off unless you are presenting. And yes, please put your mobiles on silent mode. Okay, so it's next. Standard thing. I guess you already know how to get the Meet Echo. You probably don't need the direct link because you can get there from the agenda. I did ask for minutes taker, but then we decided, I think we can just give such a popular thing as AI another try and see how well it could take minutes for us. Because anyway, right, if you said something on the mic, you should check minutes later to make sure it's been captured correctly. We all should be using the most recent version of IP protocol. And should not be using the legacy one anymore. And as far as I know, even Microsoft Windows devices might start using v6 mostly. So if you have a Windows laptop, please let me know how it goes. I'm very much curious. Agenda. So we as chairs going to talk a bit about documents and how we operate. And then we have 3 working group drafts to talk about. It's been a last minute shuffling of the order because David asked to present at the beginning of the session. And then we're going to have 4 individual drafts. By the way, the last 2 drafts, as you might see, look very similar to each other. That's why the last 10 minutes we probably might spend on discussing those drafts together. So I'll remind you later, but when we will be when those drafts are presented. I suggest you can ask clarifying questions about the draft specifically after the draft presented, and then we can talk about their differences and how they fit, how they work together after both drafts are presented, have been presented. So what we've been doing, are we making any progress? Well, we have not published anything, but looks like the famous cluster 525 has been unblocked. The story was we had a number of drafts which were waiting for SNAC document. They got stuck in the normative references. It's been unblocked by moving a SNAC simple from normative to informative for array flag, which also unblocked 6724 and also another draft from v6 ops. We have another draft sitting, again, waiting for a reference in RFCQ, and another draft is for segment ID clarification is waiting for RFC editors. There are two drafts waiting for write-up. One of them is mine. By the way, if you are one of the authors of this draft, I mean Discovery Young, I did send you 2 emails asking for some clarifications for write-up, so please take a look if you have not seen my mail. So we have one draft which is still in the working group last call is Slack Renam. As far as I know, as far as I can see, there is some discussion going on in the mailing list. So we do hope, fingers crossed, to make some progress on it. Zafar, you have questions about what I said?
No, I wanted to mention the same thing. For the first draft on this list, there are significant comments that are on address and concerns. There is some discussion going on with the authors, but the convergence is not happening. There are certain things that they say that the working group agrees that we can do this, and I want to bring that topic up is what it means when the author says the working group agree they can do what changes have been proposed, and how the chair would like to take that comment and progress, because as such there are serious concern. This is something to be done in hardware, and the current encoding is super complex and is not consistent with what discussion has happened. Author went in a route which is not consistent with what discussion was happening. And there's also a 32-bit ID with the context that somebody can hijack and put something like application ID in it and all. So that could be a bit concern for privacy and that point of view also. So I think we need to check is how, because like authors are willing to work with the comment, but they're also concerned what would the working group do if I would make that change at this stage. So anyway.
Okay, thank you. Yeah, I know there is some email discussion going on. Yes, so we'll continue on this. Okay, so what other documents this working group is working on? So we have 3 active documents which are presented today. However, there is a number of active documents which are not presented and we have not seen recent updates. So I just like to remind the authors that that we'd like to hear what the plans are for those documents, if the authors still have energy to work on them. However, we have 3 interesting documents. We have one document which is still active. It has not expired because it's been updated a couple of times recently, but those updates do not actually change the content of the document. Yes, and so the first document is basically what I call dormant, right? So no changes, authors keep it active, but does not seem to be any actual work happening. And there are 2 documents which are expired, but officially still belong to 6man. Yeah, one expired for 9 years, one for 16. So my proposal is that unless someone object to this, and please raise your objections before September 1st. The date was chosen randomly, but we are going to eliminate those documents from the 6-month working group. So putting them back to individual documents, and then, because it looks to me, it looks to the chairs that nobody is actually willing to work on them, which means the status as working group document is not actually correct, right? So if someone is willing to pick that work up, we can always go through call to adoption again and do this. So yeah, Tim, are you joining the queue?
Yes, sorry, Tim Chan. Yes, I'm trying to. My question was whether you can very quickly summarize what the point of the 4291 BIS was. There must have been a reason for it. Has that completely gone away, presumably, since it's been dead for 9 years?
I don't remember what happened yesterday. You just asked me what happened 9 years ago. If you are interested, we can. I probably should have prepared a short summary, but probably Bob remembers something, but
Bob
Yes.
will know.
So what at least I remember is, can you hear me okay?
Yes.
Good. What I remember is that the working group completed it and it advanced to the ISG, but there was comments in the IETF last call about how prefixes were represented and who should do that and so forth. And it was essentially couldn't reach IETF consensus. So it sort of stopped. There were a lot of other, I think, good changes in that document, but it doesn't seem to, I'm not sure that the thing that caused it to be blocked would change.
Georgia?
Maybe for each of these documents, before doing the September 1st thing, you should send for each of them, not one for all, a message to the list asking if some other people want to take over, and if possible, summarize what were the issues like what just Bob mentioned. So we can take a more, let's say, informed decision about what to do with each document.
Okay, yeah. Why I do not see the queue on my screen?
Ron is next.
Ron, I am in the queue. I found the queue.
Ron Bonica, HP. Quick question about the reflection draft that's sitting in a missing reference state with the RFC editor. The missing reference is to RFC 8335 BIS. That document appears to be stalled. Would it be okay if the authors of reflection referenced RFC 8335, made whatever changes we need to make the reference work, and push it out of RFC editor queue?
I said, I just do not remember. Does your draft need anything from the BIS or just A335? I just don't remember what kind of normative reference is there.
There is one paragraph about something that BIS clears up that the draft could do perfectly well without.
Oh, I can see responsible AD coming to the mic.
Hi, Eric Vink, responsibility both for this and for the RFC 8335 BIS, which is the inter area, if not mistaken. Right, the BIS document is waiting for revised ID for 200 days or something like that, so should be addressable. Now, I remember somehow, I don't know whether you check Ron today or whatever, but I remember that the BIS was useful for this document. I did not prepare anything, right? So that's, yeah. But I would prefer to apply pressure from the 6-month document to the interior document so they get moved forward, right? Because then you actually need 2 plates out of my chairs.
Okay, Ron, I think we can talk offline, but I suspect we both know who the authors of the BIS are. So maybe the authors could do something.
I confess.
Okay. Yeah. Important thing, just a reminder, we show this slide every time. I IPv6 is very important. A lot of other technologies from other working groups using it. So every time another technology requires some changes in IPv6 protocol, such as, oh, I need a new option, or I need a new bit somewhere, right? We kind of have not a problem, but interesting situation when the draft coming to 6-man might be actually proposing something to solve a problem which is in the charter of another working group. And as a result of it, sometimes the discussion around the draft might be not about what is this option, like is the proposed option format or bit is a correct approach, but about the problem statement and if the solution proposed is the correct one. And sometimes this working group might not be the best place to have this discussion. So as a result, just to save working group time and energy, we are trying to apply the following logic. If the certain draft requires changes in IPv6 protocol, we first would like the original working group, or at least the chairs, to tell us that the working group considers this problem worth solving and solution being correct. So normally it means another working group needs to adopt a draft, right? And then after that working group decides on how to solve the problem, we can implement the required protocol changes. It happens quite a lot in Spring, obviously, right? Because SRv6 needs some changes in v6, but I do see it in cases of other working groups as well. And it's not like we do not like to take work in 6-man, it just we'd like to make sure the solution itself is discussed by the people who have context and have expertise and interested in what is being discussed. Eric.
Why this noise when I come to the mic?
Oh, I'm happy.
Okay. Anyway, Tim Winters is there, right? So that's exactly what we are doing in the HE working group. They are pushing basically all the definition and the semantics of an option into the other working group. And then the HE is not even consulted, or basically we extend the working group class code. You may want to say a few more words, Tim, if you want.
Yeah, I mean, that's how the group is basically run for the last, I want to say 5 years, is that we let other working groups do the actual work and then they run it by us. It makes more sense because the options, in our case, they're pretty well defined. I think 6-man, I think there are places where things are very well defined, and I think those are fine to do, but obviously there are some spots where things are not so well defined, and that's where we end up in trouble.
Yeah, we mostly put on the slide on because we do receive a lot of agenda requests from other about the drafts which are not even adopted, and sometimes that other working groups are not even fully aware of the proposed solution and even about the problem itself, right? And I see that sometimes we do not want to waste too much of the working group time here yet.
Ted Lemon. So just to clarify, does this mean that if we were to do something similar to the router advertisement, the snack router advertisement flag again, we probably would not do it as a 6-man working group document?
No, we can do it a similar way to do, we did it with array flag, but with array flag as a good example, it was already SNAC document being adopted. So SNAC group already decided we want to do this, and you came to us with just a very short 1-page draft saying, we need a bit, and we already know we need it. So please define that bit for us.
Okay.
We happily did that, right? So easy.
Yeah, just checking.
But we did not need to discuss how exactly this flag is going to be used. Is it the right thing to do, and so on. It's all been uploaded to SNAC, is what I'm trying to say. Sorry if I wasn't clear.
No worries. We may have another one coming. That's why I asked.
Okay.
DNSSD this time.
And Jen, you might want to talk about the request we got from, what was it, Savvy, where it was basically a protocol draft, but the Savvy working group is not at the point where they were looking for technical solutions yet, as I understood it.
Yeah, there was another example here when a certain draft came talking about ICMP changes to solve a problem while the whole working group is still in the architecture phase. And problem statement phase, not even architecture phase.
Right.
So they were like few steps behind. So it was definitely too early to discuss the solution, and just another example, yeah. Okay, and oh,
Just to close the loop on that last bit, as the SAVNet co-chair, yeah, SAVNet was the working group. The SAVNet working group is very carefully tiered in how it is supposed to work on things. There is no way we are going to be agreeing on solutions, approaches even, at this stage of the effort. So taking up 6-man time on evaluating a solution is distinctly premature, and we very much appreciate your checking with us on that. Thank you.
great, thank you for that comment. And I think this is the last chair slide, so we can now finally go to talk about actual drafts. So David, it normally takes a while for me. You have preferences on which one you talk first?
The 11 one first.
Okay, 11.1 first. You want clicker, or I can do it voice control?
I can do
Okay, because this takes longer. And now I need to do a few more clicks. There you are.
Hi, I'm Ikwi, and we're here to talk about 802.11 and IPv6 again. Let's do a quick status update first, in case you've looked at this before. The main change that has happened since before was that I've tried to figure out where this would need to go if it were to go forward. We don't really have a liaison to the Wi-Fi alliance. We don't have one to 802.11 either, but this can be figured out. I know roughly what direction I would need to take this in. I did get some feedback where now I want to be sure what exactly I'm carrying somewhere before I go start that. So let's maybe try to figure that out first. This is a Groundhog Day thing, definitely. We've discussed this before. We are talking about IPv6 doing RAs on multicast, and that then being multicast on Wi-Fi on layer 2. If you lose enough of those, you lose IPv6, and then, yeah, you don't have IPv6. Some devices, they just decide that IPv6 doesn't work, and they don't even try anymore. Sometimes it's intermittent. We've discussed this multiple times before. You can see the list here on drafts, and actually one RFC that talked about this before. Right. Why is this a problem? It's a problem because power is expensive, and it's too much to be waking up every 0.1 second. 0.1 second is the default beacon interval. You don't get multicast every beacon. There's a multiplier for that, and that multiplier is configured in the AP. The client can't do anything about it. It needs to live with what is given, unless you have either FMS or DMS. So those are two things in 802.11. I'll get to that a bit later. In the previous attempts that we've taken here at looking at this, neither FMS nor DMS have received a lot of attention. That's the main reason I brought it this time. All in all, this is some summarizable into numbers. 5 is what apparently most Wi-Fi chipsets have decided is acceptable as a minimum multiplier to wake up at. That's multiplied by 0.1 second, so that's 0.5 seconds. If you have a multiplier that is lower, i.e. more frequent DTIM messages on your beacons, the chipset, not even the host, the chipset decides that that's too much power, and it will just sleep through those beacons and not get the multicast traffic. It's a little hard to figure this number out. The way to get that number is basically you buy devices and you see how they behave in the real world. This is not really documented anywhere. The other number here is 2, which is the default value in both OpenWRT and host APD. Host APD matters a lot because any cheap AP is just host APD. And obviously 2 is less than 5. So in this combination, you lose 2/3 of multicast traffic. You can't do 5 if the multiplier is 2. You need to do 6 in that case because you can't do an odd interval. But this is the problem in a nutshell. We lose 2/3 of IPv of layer 2 Wi-Fi multicast, which if IPv6 arrays are transported over that, that's 2/3 of arrays. First thing, yeah, we can absolutely try to change those numbers. I've contacted the OpenWRT people. I will try to get that done. I believe it's been tried before. For host APD, I know people have tried doing that. Host AP is hard to get things into. I have not tried that one, and I probably won't try that one because that's not a field that I really do stuff in. Either way, I don't think the numbers are the real problem here. We need to specify something in a way that is guaranteed to work. I don't think we can be relying on things to be configured correctly by someone somewhere, which may or may not happen. And also, we've tried this. We've documented this before, that this needs to work, and you may need to configure things in a certain way. And it doesn't seem to be working. Otherwise, I wouldn't be standing here. I don't think it's a valid argument either to say that it's fine on enterprise Wi-Fi. I'm well aware that wireless controllers do all kinds of things with arrays or just neighbor discovery in general. So you will not see these problems on your corporate Wi-Fi. The wireless controller does all kinds of magic. It will generally convert things to unicast, for example, and that's the solution done by people who know what they're doing. They know that because they have the knowledge, but we should have things in specifications that documents these things, not just rely on things being carried around. The 802.11 side has two things in the specification that are relevant to this. There's FMS and DMS. FMS was specifically designed for this issue. It allows a station to request that multicast traffic is delivered less frequently, so you have to wake up less often. Like you pick an interval, you can say 5 instead of 2, for example, and then the AP buffers the multicast packets and then sends them out at that agreed upon less frequent interval. It's a negotiation. The AP needs to have the same number for everybody that is associated on the AP, so it needs to match for all the clients. But as far as I understand, the protocol would work if only it were implemented. It was specifically designed to address this. Question right now, or?
Clarification. So if a number is decided and a new client arrives and asks for something different, what happens? Nothing?
So either the AP decides to change the number for everybody, and then it needs to notify everybody. I think there's a part in the protocol where the AP can push a new value to all the associated, to all the stations that are on the FMS stream for the one thing. I would need to check the details. I would assume 802.11 knows how to specify a protocol, and they took care of this. There's got to be something for that. DMS is kind of a cousin of the same thing. It has a lot of the same protocol elements, but instead of changing the multicast interval, it allows the client or station to explicitly request some traffic to be converted to unicast, which is already, the AP can do that by itself, but this allows the client to ask for it and receive the agreement from the AP that this is happening without just assuming that it might happen automatically. So the end result of that behavior is already common in enterprise Wi-Fi. A lot of multicast, layer 2 multicast, is converted to unicast by the AP or by the controller on its own logic without the client being involved with that. But then the client doesn't know that, and in theory, the client in that case still needs to do the normal wake-ups. It's just that if this is in use, doing that is less bad because it's also unicast conversion going on, so you don't lose the packets. This is in the, well, software is maybe not quite right. This is between software and firmware. Needs to be implemented on both the AP and the station. It will definitely take years to get this shipped if this were declared mandatory or whatever else right now. So this is not an immediate fix either. In theory, we can change IPv6. We can send more arrays. We can send RSs. We can do IPv8. We can have an AI figure out the solution. I don't disagree. I don't agree with these. That's a separate question. I do think we should maybe try multiple things at the same time here and just see which one actually works at the end. The main thing here is it's still broken. We haven't tried the 802.11 side yet. I don't know which of the two is the better thing to do here. Maybe DMS is better, maybe FMS is better, maybe both, maybe neither. Maybe both of these are stupid ideas. Either way, 802.11 and or the Wi-Fi Alliance would need to do something about that. And this document is, at the end of the day, intended to just go there, be a liaison statement to the Wi-Fi Alliance and or 802.11, tell them this is a problem. I had tried to put this more like, hello, we have a problem, and not like, hello, we want this specific solution. The people who know the most about this are there and not here, I would say. And that's it on this document. Questions? Who's Jerome?
I'm here. On the screen, yes. Hi, I'm Jerome from Cisco. Thanks a lot. I mean, this is interesting presentation, and can you hear me okay? I see you're trying to, yeah, can you hear me okay? Yeah, okay, perfect. You know, a lot of thought come to my mind when I see this contribution. First, IEEE designs standards, right? So FMS is in the standard, DMS is in the standard. So if you go tell them, hey, we have a problem, and as you say, if we tell them, hey, maybe we should do DMS or FMS, they'll tell you, well, it's there. Just tell people to use it. We're not mandating any implementation behavior. So I'm wondering if IEEE is the right direction. The Wi-Fi Alliance, of course, they have certification programs, as you know, where a group of companies get together and say, these features together will make an interesting combo that we'll call voice enterprise management, QoS, Wi-Fi 6, whatever. Thing is that FMS, is a very bad protocol. Remember, it was designed in 2008. That was Wi-Fi 5, 802.11n. Back then, you had like 10 stations per AP. And so, as you say, the question was brought by Lorenzo as well. As soon as multiple stations come in and out and start to negotiate stuff, you have a bunch of overhead that starts appearing because everybody's going to be negotiating something different. So it's going to be a bit messy. Essentially, it's because, as you say, multicast is not good on shared mediums. So that's the fundamental problem. DMS may be interesting, but it's already in the Wi-Fi Alliance certification. It's in the PowerSafe certification, so it's already there. So people who want to implement that feature can implement DMS, and they don't. Which is where I wanted to go, which is my thinking that IEEE might not be the right place. Wi-Fi Alliance might be, but because it's a combination of companies, more than the sort of the liaison from the IETF, what would be more useful is some captures or numbers that show that there is actually a problem, because what you seem to be describing seems to be what station vendors are implementing. So it seems to be that the issue would be to do something there more than implementing general protocol that the APs should do. So it seems that having more data and going to enterprises that are in the Wi-Fi Alliance might be an interesting approach to actually raise the issue more than a liaison. Just a thought.
Right. I think I understood most of that. So I can tell you, so DMS and FMS are both not implemented in host APD. So the cheap APs are not going to have it, regardless of I don't know which part of the Wi-Fi Alliance certifications includes this. I think you said that, but I didn't understand it. If we can get somehow to get this implemented, that's what I'm trying to get to somehow. I will also say that this behavior that the chipsets do to sleep through the DTIM intervals, I don't think this is specification compliant. I think
it is.
It is? Just randomly lose?
They have absolutely the right to decide. Absolutely, yes.
Okay. If you can send me a pointer or something on that.
3.266 in the standard. I can send you that number. Yeah, 3.266
okay,
specifies it specifically. Yeah.
Okay. Thank you.
I'm writing down 3.2.66. I'll go look it up. Yeah, I do agree with the sentiment here. I think the other thing, one thing to keep in mind, of course, is it'll take a long time. I guess I do think that FMS is just seems really clunky, and having but DMS might be a good idea. And if we could, it's possible that device manufacturers could try to lean on their chipset device vendors to at least request it. And then at least there would be some amount of demand. Do you happen to know if DMS allows buffering for hundreds of milliseconds? Because that's what you need here.
I don't know how long the buffers are if you enable it. I think it just gets treated as normal unicast traffic, and whatever, like however much you keep for that would also apply.
But
to
if you're going to
DMS.
wake up in 100 milliseconds anyway to receive unicast, I mean, of course it's faster because like the rate is higher, but I think my point is if it doesn't end up saving battery, then we'd still have a problem, right? So I think that's worth.
I wish I could test it, but I don't have an implementation that I can test.
Yeah. And I do agree, like, going to Wi-Fi Alliance saying we have a problem is better, but I think Wi-Fi Alliance just does the certification, so they won't know the answer. 802.11 might be the better people actually to ask, because they would tell you, we designed it for this purpose and it has these properties, but then we'd have to go to the Wi-Fi Alliance to make it sort of required.
Yeah, it is kind of in the middle, or both.
We do have a laser window too. We should probably say, look, please recommend a technology for this purpose.
Yeah.
So you said that host APD effectively blocks the implementation for all these smaller access points, right? And it's hard to get things in the host APD. And do we think it's easier to go this route versus trying to convince them that they're breaking the entire industry?
I don't know how to really answer. So I don't know that much about the host AP project as a whole. I have the outside observation that things do get implemented, but it takes time and it's hard to influence from the outside. Like if you send a patch, it's not guaranteed that anything much happens to it. But I mean, I also don't want to, like, this is mostly one person still who's controlling the project. They do seem to be doing a pretty good job in terms of host AP does support a lot of things. This is just one of the few things that aren't there.
Yeah. Maybe not them being evil, but more because the problem itself is between layer 2 and layer 3, and it's kind of tricky problem because in my experience, it's kind of hard to understand what the problem is pretty often, because if you're focused on one layer, you're not looking at the other layer. So
right.
maybe that's something.
So for the clients, so the host AP project also has the client side, and for that it's purely in the supplicant as far as I understand it. So there's no firmware or even kernel change involved. I think, like, take this with a grain of salt. For the AP side, you probably need some firmware interface or something that might not currently exist. Because if like the firmware needs to know to do that particular thing with the multicast frame, but I would also suspect that it should already be there. This is in the level of detail that I just don't have, unfortunately.
So allow me to join the queue even after Eric Vink. Just to augment what the other Eric just said, there is an official liaison between IEEE and IETF. There is even a call 2-3 weeks before every IETF meeting where we track about 30 or 40 specific issues. I will add your draft to the list. But as my colleague Jerome already said, it's not really an IEEE issue. I think it's a Wi-Fi Alliance. But Wi-Fi Alliance was quite active here for other projects, mostly linked to identity. So they know we exist and so on. But I think getting numbers could be very useful.
I will try my best.
Okay. Yeah. We are.
How are we time-wise?
Not very well, but we have some spare. But
the timer's not there.
Yes.
Perfect. Cool.
Hold on, I'll give you slide control for clicking.
Okay. More multicast. Yay. I'm still IQI. Let's again first do a quick status summary. If you've looked at this before, you can just zone out. Content-wise, it hasn't really changed. Mostly I've been trying to figure out with IANA what the actual update is to the multicast address space registry for this draft. It's a little bit tricky because for multicast addresses, there's this variable scope thing where addresses can be allocated, assigned for all of the scopes, and then it gets imported, and that makes things a little bit non-trivial in the IANA operations of the whole registry. It's still open what to do with MLD for this. Why this is a question if you haven't looked at this yet, then this will make sense later. This will also be presented in PIM on Wednesday, I believe. Yeah, actual content of this. There are some layer 2 multicast groups that have specific behavior specified by the layer 2 technology. I care about Ethernet. That's what this is designed for, essentially. The 3 relevant groups are listed here. They just propagate less than normal broadcast on Ethernet. 802.1q is what defines those. I wish I could give you the page number for the current version. I could not download that one. So there's page number 192 in the previous revision of that draft. Those I would like to expose. There's been multiple IETF documents that were heading in the direction of using LDP for discovery and establishing neighbors, and that have kind of triggered this, because the point of LDP, or normally the benefit of LDP, is that it does not traverse a switch. Like you stay on the cable, and that you can use that both as a security property, as well as if you have a VXLAN or some overlay network. It can be quite useful to have the discovery not go into the actual overlay network. You could look at these 3 documents. I'm not sure what the status is. I think, yeah, I'm not sure if all of them are progressing, but it doesn't really matter. Short version, there is IPv6 multicast address ranges that have a mapping defined that makes them use these already existing layer 2 multicast groups. So you can use them for IPv6. These 3 are the ones that I'm expecting to be useful. Specifically, the bottom one is the one that is really relevant here. The slightly longer version of the entire thing is how this works. We defined in RFC 2464. You probably saw the 3333 prefix at some point, looking at some PCAPs or Wireshark output or something. That's how normally a IPv6 multicast address gets mapped to some layer 2 Ethernet multicast group. It's really just the last 4 bytes that get copied over into the multicast address for Ethernet. And this has only received one update ever, which was to allow also putting it in unicast, which actually relates to our previous discussion. So this is, right. So this takes a currently reserved combination of bits in the first part of the multicast address, FF22. Like the combination of those flag bits currently makes no sense. And it defines that this range is used to map to something that is specific to the lower layer. And then there is a new registry for the lower layer technology. There's only one item right now. This draft is only documenting behavior for Ethernet. But a different technology at some point might want to expose something that technology already has. And that would be a different item in that registry, and it would have different groups with different behavior. The mapping rule that goes with this for Ethernet is quite simple. The whole 180C2 range is exposed. I didn't feel a need to make this more specific or anything, and this seems perfectly fine, but technical details. By logic, more or less, the scope that the packets to a group like this go out on can only ever be less than the link scope that IPv6 has, because if the scope were somehow greater, that would be the link scope. Again, like it doesn't make sense for this to somehow be larger. And that's also why this document is called sublink scope. Also, this is existing behavior. This is not specifying somehow new multicast behavior for Ethernet or anything like that. And I also want to point out, because I've gotten that feedback, these 3 groups specifically are not specified for use with some Ethernet bridge, whatever protocol. They are specified in terms of their behavior in 802.1q. That is not the case for some of the other groups in that same table, but these 3 ones that I've pointed at and that are mentioned in the document are, in a general sense, defined in 802.1q. I think this also explains what the how this relates to IEEE activity. This is just defining a way to make use of an existing feature. I do think this still needs to also go to liaison, just to, in this case, I hope this is mostly to make them aware and allow them to just, provide input if necessary. But this is, I think, much less involved. Famous last words. It's, as an idea, this is trivial. It is 31 lines of code in the Linux kernel. I will actually demonstrate this today at the hackathon happy demo whatever hour, which is in 2 hours or something. It works. If you are more interested in the why of this, you can pull up the 124 presentation, or you can just ask me. I think that's it for this document. Questions? Okay.
Right.
Thanks.
So, okay, hold on. How many, raise your hand if you have read the document. Oh, okay. Yeah, okay. So a few people are aware. I would really like to get, the chairs would really like to get more reviewers and feedback on this. Yeah, we obviously can just go for the last call and then people must start reading it, right? So yeah, okay, we'll take it offline on what the next step is, but my impression is it's actually in rather good shape currently, right?
It is relatively simple. I do think, if anything, the question is if there's enough interest. If there's not enough interest, then...
It's supposed to be, we have adopted it. So I clearly remember this group expressing the support and the interest for this document. Maybe those people are not in the room or they're just too busy with reading emails. But thank you, David. We'll continue working on it. Thanks.
It sounds to me like it may be time to do a working group last call and find out.
Yeah. Okay, so next presentation is not requirements. I'm trying to get the slide. Yeah. Click. Okay, yes.
Hi, everybody. I'm here to talk about node requirements with my co-authors, Tim, who's in the room, and John, who couldn't be here, but we have an update for you guys. So I'm going to start with this extension headers. I love talking about extension headers. So originally 8504 had text. It looks very much like this, and by very much, it's this exact text. So I'm going to show 2 slides about this really quickly. Deal here is we tried to update it when we did the first biz version of this draft, and we tried to say, hey, there'll be new RFCs. We had EH limits. For those who have been tracking this, EH limits did not go through. It ended up being, it's a dead draft now. So we thought the best thing to do at this point for the working group was to go back to the text that was in 8504. So here it is. So in full disclosure, it's the same text. I think people should see it, because the deal here is if there's been any changes since the last time we printed this, people should take a look at it. I will say this is very much guardrails. There's a lot of shoulds here. I don't think there's anything, we're not forcing anything new. This is the text that's been around for, multiple extension headers. Yeah, here's the next. This is all one paragraph in the document. And so 02 does not have this, 03 does. And it was just a copy and paste. So this is really, I don't expect people to read this right now and have comments on it. This is really, everyone go read this text and make sure you're still cool with it. If you have any comments, we'll take them. But at this point, it's just I thought I wanted to point it out to make sure that everyone knows, yeah, we're switching this back to what it was before. No changes at the moment. Okay, so other changes we made in 03.
By the way, so Ron, did you have a qualifying question on this?
Yeah, please.
If you could go back to the last slide.
Yeah.
A host may. No, I thought I just saw a paragraph on a host may disallow unknown options.
Yep, you did.
Okay. Isn't that a change to 8200?
Oh boy. So I do not think this is a change to 8200, but like I said, this is how this has always been written. So,
if you could explain why it's not a change to 8200.
well, so it's a good question. This has been an open thing that we've run around this a little bit in the past. Right now, 8200 and 8504, they're supposed to work together. Ron, this is a great question. I have to go back and look at remind myself what we did with this one. It says a host may disallow unknown options in destination or hop-by-hop options in particular.
Yeah, disallow to me means discard the packet. Is that what it means?
It means to be configured to do that. Yes, I would.
Yeah.
That's how I would take that.
And if that's the case, we have to think about backwards compatibility for an implementation that was written the day after 8200 was written.
Right.
But
So
before 85.
Right. The next sentence has sort of always been our get out, right? This should be configurable where the default is to accept unknown options, but a host to protect itself might decide that those things are evil and should be shot.
To me, that means that you can configurably violate 8200.
Well, I mean, you could configure a lot of things to violate 8200, right? I mean, go nuts. Like, I hear what you're saying. We've had this text for a while. I think it's an interesting point, but yeah, I mean, this is what we've had.
I think we agree on the facts. We disagree on the
I think
politics of it.
I will say we've drifted into a gray area. I will admit that for sure.
Yeah, Tim Chown is co-author of this. So the reason this text has come back is because of what happened with EH limits. This text has been there in 8504 since 2019. It's been around for quite some time and agreed by the working group. And after 8200 was published, therefore 8504. And this text is all about protecting the end host, the receiving host, not what happens with forwarding on the path or the sort of things that Brian's draft and other drafts speak about. And the default is here to process them as per 8200. So it's an additional protection. Yes, I get what you're saying, that it's, but it's there as a protection. That's the point.
Is there a problem with contradicting a document of higher
Yeah, I mean, so I'll say this, right? When we went through this the first go around, right, 82 was already printed when we did 8504. So it wasn't caught then. That doesn't mean it's not wrong. I think we can talk about this. I don't think the intention was to change what 8200 says here, where we're just giving hosts a way that they might configure themselves to protect themselves from extension headers, was my memory of this. So I hear, you know, if you could, Ron, send me a note on 6man so I don't forget this, and I'll log a story for this and we can talk about. I don't have super strong feelings about this, and maybe this is one of those things that's changed since we printed this. Yeah, I was thinking the same thing, Tim. That this paragraph might disappear, might be what happens, but send me a note and we'll talk it through.
Hold on. Question. So we explicitly talking about host here, not node.
Yes, this is very explicit. Most of these protections are for the end device, not for forwarding. That's a good distinction to make. Okay, any other things on extension headers before I move on? I love extension headers. All right, Justin. Oh, okay, this will be fun.
Yeah, Justin Yeoman, 6wind. I think we could just borrow this paragraph and put it in the extension headers occurrence draft because we are updating 8200.
Right.
That would simplify things, right? I guess.
Yeah, you know, that was one of the things, obviously, we'll get to the end of, I'll cut to the end of, the spoiler alert here is we're going to say we're ready for working group last call at the end of this. And so that's where I think your draft's going to be behind us. So I think that, yeah, I think it's a good starting spot. I'll say that. I think this text is a good starting spot for that discussion for sure. Okay. We get some I get some layups here. So this is PMTUD. We added some stuff before. Gory, I think, was the one who reviewed this and said, hey, you should be a little more explicit. So we are now. I don't think this is earth-shattering to anyone in the room. We're just saying, hey, go read these RFCs. This is actually what we mean by those things. So I think it's minor, but we did make the change. All right, this was an oops. And this has been here for a while. So we have some ECN stuff. We didn't have diffserv in the doc. So we put diffserv in there. I don't think this is anything major, but this should have been added probably if we added ECN. So it's there now. That's the text we added. All right, keep going. Good. Okay. Perf 6.4 in router advertisements. Okay, so we had 7050. I have some more questions about 7050 later. This was the text we used to have for this. We've updated it to say may support this. And Lorenzo is going to get up.
Isn't there some other document that says should not do 7050 somewhere?
So I was telling Tim before this, we've been around this mulberry bush a bunch of times with what to do with the 7050 text. I think later I reference a different RFC, and I'll jump to that, the newer one, the one from the last one. The last one about this topic, I think might just be the move here for us to say, this is the latest information that says, go do 8781. The thing, I think when we originally wrote this text was for the local synthesis part of this, but I'll defer to others on this topic is where I'm at with this.
Definitely we must at least remove the should.
Okay.
Definitely remove
We definitely took out the should, for sure. We took out should and said, hey, do 8781, and they may do it. I'm guessing the may is for older implementations that need this, but
well, so there's a variety of things. We must remove the should. Then we can say nothing about 7050, or we can say may support 7050, or say should not support 7050.
well,
but at least removing the should for 7050, yeah, we should.
yeah, I'd be okay going silent on 750 if the working group's cool with that, but it's not clear to me the working group's cool with that. So, yeah.
We don't do ham anymore. Eric Vink, just a heads up and a warning. Uppercase should is BCP 14.
Yeah.
It's for interoperation. And when you write a should, there's a clear guidance that you need to explain. If you don't do the should, what will be the consequence? So basically,
Yeah.
you really think a lot. Why don't using a must? You can use a must unless.
Yeah, so the text above has a little bit of that, Eric, but I'm in agreement with you here. This is one I think we could probably write a little bit more about why it's a should, but I didn't include the paragraph above this. There's a paragraph above this that talks a little bit about why you would want to do this.
And this one should be easy to do. I should, haha. But there are other should as well in the document that
Fair.
need the same.
Yeah, I heard.
Yeah, Tim Chan, and there's a difference between implementing and using.
Yes.
As well, you might want to. But there is that RFC 98 something.
Yes, that one.
Talks about this, and that's the thing we could.
That's the one I have later in this. I
Yeah.
promise that one's later.
But Tim and I have had a discussion about this, and in a way, we're kind of thinking, well, should we just say nothing? Because as soon as you mention it, you get a lot of opinions. But I think we have to say something. And the question is, where is the long-term future of 7050? Are there going to be things around that will need it indefinitely, or can we push harder now? But I think you've got a slide later anyway.
Yeah, I do. I mean, what I'm hearing right now from the working group is yank 7050. So I think that's what we're going to do.
Okay, let me say, yes, we published 9872, which says should do array option and may fall back to 7050 if it doesn't support it. However, there is a disclaimer saying we do not apply that requirement to mobile devices. And the reason is some mobile operators very, very explicit that they don't want to do Pref 6.4, and they're very happy with 7050. So basically, making 7050 optional would break devices in mobile environment. So maybe what you can do, you can just you can just refer to 9872. You can just say the device must discover Pref 6.4 not 6.4 prefix somehow. There is a 9872 which describes the current recommendations for doing this, and just avoid all this problem altogether, right?
Yep.
The only problem would be, I think, that RFC is informational, so it's going to be a down ref.
Well, right, but yeah, let me.
But I think it's manageable.
Yeah, I'll take a look. Well, Tim and we have a ticket for this. We'll go look at this and come up with the right thing, hopefully. Yeah.
Because I just don't think it makes sense to repeat the same text from the same text in multiple RFC about how to discover the same thing. Because if we eventually want to update 9872, For example, if we invent another shiny, beautiful way to discover Pref64, we might just point all other RFCs to that one. But
Yeah, I mean, I think this whole section, my memory of this is we say at the top of this that, hey, if you're doing transition mechanisms, you're going to want to go read these things. I think we can say that and get ourselves out of this should-may discussion and say, go read these documents and make the decision on your own if you're a V6 node, which might be the smartest thing for us to do.
Because I just realized, what if I'm in theory have a device which I just configure with Pref64 statically, I don't know, like servers or something, right?
Yeah.
We need to say the device should support discovery and how discover.
Right. I think that's the thing we might want to just say in this case. Hey, Jordy.
I think there is a bigger problem with 7050. My experience is that many operators implement 7050 or not implement it at all because through the 3GPP specifications, they can already announce the DNS, which has already DNS64 support. And the bad thing is that the 7050 was updated by 8880, if I recall correctly, and this is not being done. So what happens is that actually 7050 alone doesn't work or doesn't work correctly. And in most of the implementations of IPv6 in mobile networks are not using RFC 8880. So if we mention 7050, I will suggest that we should also mention 8880, not just 7050, even if it's updating that document, but the people don't realize that.
Yeah, I mean,
I think there is something really broken there, and I really think we should deprecate 7050 actually.
Okay, Jordi, if you manage to convince mobile operators to do array option.
Yeah.
Not to bring up another problem, but like this doesn't actually do anything, right? It's like should support RFC at 781, and then okay, I learned in the Pref64. What do I do? Log it to std. Like, am I supposed to synthesize? Am I supposed to do?
Well, I mean,
about
right. So the original was to perform for V6 address synthesis in a V6 only environment, right? So we try to deal with that problem. We can argue about whether we do it the right way or not, but we tried to be clear that we weren't.
Is how to perform local address synthesis defined in any RFC? No, I just say like this is a standard Strat document, right? Yeah, because like 8781 says like here's the format of an array option that you can look at, and that's fine, right? You can implement that, but it doesn't say what you're supposed to do with it. Anyway, I like don't want to rat hole here, but it did.
Like I said, I think our goal here is to tell people if you're interested in this, go read these things, right? From the general node requirement document would be my.
That's what Lorenzo just mentioned is one additional problem. How local host can do self-synthesis or local synthesis is described in RFC 7, which the DNS documents 6147, I think, or 40, yeah, DNS 64, okay? Is described there. The problem is that we are using three different terminologies. We are using stop synthesis, local synthesis, self-synthesis. So it's really confusing for many people.
Yeah. I mean, this is, we're talking about, we want to mention that this exists and nodes should go read this stuff, I think is really the goal of node requirements when it comes to these things. I get leery of us trying to tell people what to do in these scenarios.
I mean, 6147 talks about the DNS64, which in this situation doesn't exist. So I think all of this text is kind of not really. Yeah, I don't think this is defined anywhere. I mean, we should define it, but
yeah, I have to go back and read the whole section. I think really here what we were talking about is trying to do V6 only, and some of the things people might want to go look at is my memory of this. But I clearly need to expand this text and before we'll take another look at this section for sure. Thanks, guys. This is, like I said. Okay. We made some other minor changes. We had some SVCP. Someone gave us some. We added those as DNS records that should be there. We removed EH limits for the reasons I discussed at the beginning. Those were just minor changes. Pending updates. So we have a couple things going on here. DHCP v6. I feel awkward about this as an author of that document. I forgot that we we don't have it in this document. So we're going to fix that. It'll be 9915 for sure. It needs to be updated to that. So this document will point to that. I'll make that update this week. CE router, I think Brian Carpenter pointed this out. I can't remember on which doc. I think he pointed it out on 7084. They both reference each other, oddly enough. 7084 points to general node requirements, and general node requirements points to 7084. They're both going to working group last call very soon, so I think we're going to be fine. But they should both update and point to the biz versions of each other. That's okay. There's a couple of other minor issues we have listed. I put the issue tracker here. If you're really into this, it's on GitHub under Tim's account. We have issues there. Feel free to torture us with more if you want. It's up to you. So they're there. Some of the other things I did want to talk about for the working group in this document. One of them, I think we heard today, default address selection is finishing its update and we'll get a new RFC number. Do we want to update to that as a working group was one of our questions. I'll start with that one. Do we want to say, hey, you should do the latest one? I don't see any reason not to, except for I'm wondering about implementations a little bit with this one.
We had this discussion at some earlier 6-man, and I think Ted Lemon was like, you should say must, even if nobody implements it. And I think I would agree with that.
Okay.
For what's worth, Andrew's implementing this, at least.
Okay, the update. You're doing
at least there's going to be one.
Okay.
6724 BIS.
Biz, yeah. Okay.
I think the non-local ULA is really important. So, but yeah.
That's okay. I'm getting thumbs up. Okay, so that one we'll put in. I'm not scared of this one. I just wanted to make sure the group's cool. So we'll add that one. And it sounds like it's clearing through it's going through the RFC editor queue. So that's a good one. That one's easy. Slack renum. What do we want to do with this one? I know this is also going through.
It is in the last call. However, I'm trying to remember what. Yeah, okay. So yeah, Slack renum is going to the last call. I know, like it's in the last call. So there is a few things which we need to discuss. I mean, reviewers going to discuss with authors this week, hopefully. So I can't explain how much I'd like to move this document forward. So we'll put a lot of effort into it this week.
Okay, I mean, the answer for node requirements might be not this rev, maybe in a future one. As we all know, eventually we have to pick this document up again as things get updated. So we're just down, this is where we're down to the last, whatever is currently in flight and how we want to handle them. And Slack renum was one of the ones that is clearly in flight, and it's been in flight and we weren't sure how to touch it. I think if no one has super strong feelings, I'm tempted for that one because it does have some changes in it that we just let it lie for this go. But if people have super strong feelings, please send something to the mailing list or jump up to the mic like my co-author is.
Yeah, Tim Chan, I think the Slack renum work is good, and I think we should capture that in essentially the guidance that node requirements is to implementers. So it'd be a shame to, they could still find it, of course, but it would be nice to have it in there as something that they would be more likely to look at. And similarly, the 6724 update is the same thing. It'd be nice to have the ULA benefits in there as well.
Okay. Heard.
I mean, I think the only concern with Slack renum would be like, the fear of getting stuck in misref for a while. But I mean, Jen's right. We need to get that out. I mean, well, I suppose we disagree on that particular issue, but I feel it's really important to allow zero valid lifetime arrays out. And yeah, we disagree on that issue.
Okay.
While I'm here for the synthesis stuff, what you could say for the document concretely is you could say 8781 is required, and nodes are supposed to understand the array option and somehow make it available to user space or to apps.
Okay.
And then that's because otherwise, if you talk about synthesis, that's involving a bunch of other things like the system resolver.
Yeah.
May
Okay.
not do
That might be our way out here. Thanks, Lorenzo.
because otherwise it's you have to specify something that's unspecified, and yeah, it turns into a
Mess. Okay. Okay. So, oh, go ahead, Jen.
I just put myself in the queue so I don't forget because
Okay,
I really
that's
want
fair.
to say something. And
Yeah, that's fair. Okay, so I think based on the feedback we got today, I didn't hear anything that terrifies me. We're going to put out a draft 04 this week, and then we think it's ready for a working group last call. I think we've had enough time with this doc, and it's time for it to go to working group last call from the author's perspective.
Good.
Yeah, Janikova, no hats on. I'd like to, I'm sorry, but I might open a small can of worms here. I had interesting discussion with some routing vendors this week, and I was pointed out that there is a certain IANA registry for special IPv6 addresses, and some of them, for example, are not supposed to be forwardable.
Oh boy.
And apparently, no vendors which produce some nodes are not aware, or at least not required, to do anything about that. And so what do you think about how can we make a node comply with properties of special addresses?
So, I mean, right. So I have some experience with this, unfortunately. So my quick answer to this is there are lots of test programs that exist in the world that deal with this problem and making sure that devices properly add those addresses. There's two things that happen with routers in my experience. One of them is that they allow knobs based on customer feedback to make questionable decisions. But the default is typically what you would expect. But occasionally, people make decisions that they want to forward specific addresses for operator requested reasons, is how I will put this. So from node requirements, I think we want to stay away from that part of it. I think there are plenty of wonderful compliance test programs that exist in the world that can test those things and tell you that you actually do it per word. I think my gentle reminder here is that if customers want to do something, they're going to ask their vendor, and their vendor at some point is just going to be like, sure, if you want to do this, go ahead. Buyer beware situation. That's basically been my experience with the situation you're discussing, is that we've had people come in and allow forwarding different addresses for various reasons. So I don't think node requirements needs to say anything about that because it's covered in the other RFCs that cover address forwarding, 4291, for example, or pick your favorite one. Does that answer your question, Jen?
Yes. I just wanted to bring it to the group attention and the author attention.
Yeah.
I actually don't even have opinion on that. I just realized.
In general, I think node requirements, I mean, like the US Gov profile, for example, is based on node requirements, but it doesn't go into that level of detail. It just says you should do 4291 that has all the wonderful text about address types. Hi, Ron.
Maybe it would be a good idea to protect vendors a little bit, to say, if you're going to break a rule, at least make it configurable.
Yeah. Yeah. I'm trying to think. I'd have to go back and look. I don't remember if we've done this anywhere else in this document. That's a good question, Ron. Let me check that. My experience with this is, yeah, if you're going to do that, if it's not a default / what we expect, you should do the right thing.
Yeah, maybe it should be a great big global.
Yeah.
Like for any rule you're going to break. If you're going to break it, only do it when you've configured it to break it.
Okay.
And with permission only.
Yeah. Okay. That's a good point. Okay. Yeah, I think that's, from our perspective, I think we're ready for working group last call on this document, and we can do it again in 10 years.
Perfect. Thank you very much. Yes, so we'll wait for next version, and I guess issue working group last call. And I would really, really ask people to read this because it's a very important document, right? If you do not read it, do not complain later. The nodes do not do what you want.
I promise this is not as long as some of them actually. It's relatively short. It just points to a lot of stuff.
Thank you. Okay, okay, we're done with working group documents. We should start talking about individual drafts. The first individual draft on agenda was actually Jeff, but I do not, oh, you're in the room. Thank you, Jeff. I'm getting the slides up. Yeah, and I'm getting clicker for you.
Is that the clicker?
Yeah.
It's only 3 slides. Hi, my name's Warren Kamari. This is a draft that I think you first saw in Shenzhen. It doesn't say much. It's basically a proposal to increase the loopback single/128 address in v6 with a larger prefix. The draft proposes a /96 prefix for that purpose. That's the proposal. The last time we presented it, we actually did suggest a particular prefix. The discussion on the proposal wasn't whether the idea of a prefix was good or bad, but a long discussion about numerology. Numerology managed to get us absolutely nowhere. Quite frankly, it's not a discussion I certainly wish to have, speaking as Warren, and my co-author Jeff is not keen on it either. So the way this works is simply a proposal says make it bigger, make it a /96, and quite frankly, leave the numerology to IANA. It's not my problem. And if it wants to be your problem, go speak to IANA, not to me. I don't care. Today's request that you adopt this as a working draft. That's it. Any discussion on numerology, I'll walk away.
No. Let me be very careful of what I say then. Please ensure that whatever prefix is selected has a clearly defined interface index length. Because 4291 says, according to the first three, if you know all interface identifiers except ones that start with 000 binary have 64-bit interface IDs. So if your prefix is /96, then you're kind of in conflict with that. If it's in that 000 space, then you can't have an interface index because your interface index is undefined. And so I think, yeah. So, sorry, I didn't say pick any specific prefix, but there are these things that you have to work around.
It's a numerology comment. Talk to IANA.
No, it's a property of your prefix, it's a property of your prefix, not exact prefix. So
So you think a /96 is the wrong number?
No.
Okay, fine. Next.
So Eric Vang, responsibility for this. So adopting the draft without a specific prefix, I'm all set, right? It's no problem. But before it comes to the ISG and the group last call, I think we need to get all the requirement for such a prefix, pretty much like Rosa said, but listing. So the working group needs, because the experience running a IPv6 network is not IANA, and they are pretty good, right? They're nice people, but it's in v6 ops and here. So we need to get all the requirement for this prefix.
The joy of this process that we're all enduring with such, enthusiasm is the working group adopts the bloody thing. Then we can talk about requirements, etc., to help IANA guide itself in numerology, and then it goes to working group last call. So you're leaping ahead by a couple of process steps. I'm not disputing them, but I'm saying it's over and above exactly what's going on right now.
As I said, I have nothing against adoption right now.
Fine.
Yeah, actually, as an individual, a supporter.
Thank you.
Okay, great. So we'll issue the adoption call. Thank you very much, Jeff.
Thank you.
Okay. Next. Sorry, I'm multitasking and I'm not very good at it, apparently. Okay, so now we have flow labels. Okay, let me get the slides up. Flow label. What happens? Sorry. Great. So, do we Julian, are you online in the room? Ah, cool. Do you like to take the slide control?
Can you hear me?
Yeah, I can hear you. Do you want to get a slide control? I'm gonna give you.
Yeah, thank you.
Okay, hold on. Yes.
Okay, okay, I can see the button. Thank you. So, hello everyone. This is Jia Yuan from China Telecom. Today I going to talk about the solution for the our Rocket V2 flow level load balancing method based on the IPv6 flow label. Okay, I touch the button and it doesn't move.
No, it's actually, I can see the slides moving. You're currently on the problem statement.
Okay, perhaps I have a network issue, so from my side, I see nothing happened. Okay, it's fine. Is it in the second page?
We are in the problem statement here, slide number 2.
Oh, okay, thank you. So first of all, we're gonna talk about the problem statement. Because AI HPC workload rarely heavily relies on the Rocket V2 for high throughput, low latency data transfer. But however, multiple parallel RDNA sessions from the same host may use the same file trumpet, and the traditional ECMP hash based on the file trumpet may not identify different RDNA sessions, so it will send it as a single thread, which will result in the elephant flows are all hash on the same path, and lead to the network congestions, packet loss, and significant performance degradation. Okay, next slides. So our solution is to use the QP number to identify the different IDNS sessions. In the first step, we just need to phrase the two QP paired number. One is destination QP, and another one is source QP. We use it as the interpret and combine with other interpret to hash to generate a flow label to IPv6, which may create the necessary difference that file trumpet cannot provide. So here is the detailed for the flow label generation process. First of all, we use two QP pair and IPv6 address to combine hash together with the algorithm CRC32, which is a fast hardware-friendly algorithm to generate 32-bit CRC hash results. And then we take the only lower 20 bits of them to write it into the IPv6 flow label, which finally can let the network device do the ECMP. Oh, sorry. For the implementation point is performed by the ingress network device, which can transparent and host operating system and applications, and of course hardware. So the benefit is we can achieve the 5 grand flow load balancings and reduce network congestions, and also improve our throughput. For the security considerations we only modified IPv6 for labeled, and will not alt IP address on the port number or something else. And standard security considerations will front replies from the RFC 2637. Okay, that's all for our contributions, and the next step we would ask for more reviews and comments and to improve the draft together. Thank you.
Thank you. So I'll put myself in the queue with no hats on. I did read the draft and I was a bit confused. So which device actually does this to flow label? Is it the same device which creates IPv6 packet, or it's some intermediate device which routing the packet?
It's from the ingress ingress node device.
So basically it's the device which forms an IPv6 packet.
Yeah.
Okay, so because I think your draft would benefit greatly from explaining this clearly, because the abstract says about routers and switches modifying flow label, which confuse the readers and gives impressions that actually some intermediate devices receiving IPv6 packet from its neighbors going to do something with the flow label on the path. And this is like huge difference. So I think it needs to be clarified, especially for people who are not familiar with technology. Thank you.
Okay, thank you. Thank you for your point. We will clarify it in the next version.
Now, Lorenzo Calidi, I'm confused about whether this is the same as RFC 7098, which defines load balancing on the flow label. Is it the same as 7098?
Sorry, for which RFC? 7098?
The RFC 7098 defines load balancing on the flow label. So that's already an RFC, right? Is what you proposed the same as RFC 7098, or is it different?
I'm not sure about because I didn't read the RFC 7098, but I need to check out later.
Yeah, well, you should read it then, because it provides a way to load balance, and I suppose you could extend that to ECMP. The other question I have is, why can't the packets be emitted with different? Clearly, if you're using ECMP, you probably have separate flows, because otherwise you'll have reordering within a flow, which is probably going to impact performance. So just a question, like, why can't you change the source port?
Do you mean in some scenario it will not have source QP, right?
Your first slide said that the 5 tuple is always the same, but that seems like a bad design, right? If you go to the first slide.
Yeah, please go ahead.
If you go to the first slide, it says the 5 tuple is always the same.
First slide.
Maybe we can take it. This is my link,
Okay,
please. Yeah. Okay.
Okay. Thank you.
Ron Bonica, HPE. I'd like to first answer Lorenzo's question. This is mostly overlapping with the RFC, but there is one point of difference. He talks about how to generate flow labels. That doesn't need to be standardized. It's a purely private behavior on the part of the source. So the question here is, what needs to be standardized that isn't already?
The main idea is to use the two different QP as the more interpret. So this is what we want to standardize.
That's a purely private behavior. It doesn't need to be standardized. You can do it and not tell anyone about it.
Yeah, Ron, I agree. So I didn't make that comment because it wasn't clear for me if it's intermediate host or source, but yes, a host which forms the packet can put whatever they want into flow label, obviously. It could be an informational or even maybe BCP for hosts, right? As I just do to document the implementation model, yeah.
Tim Chan, just a very minor point. Can you in your draft clarify in your you've got a section of terminology that an elephant flow is data where it's the identical 5 tuple. Some people don't have that same definition, but I think that's what you mean. So if you can state it, that would be useful.
Okay, thank you.
Just so that I understand, is the idea that this can be done either by the same host as a part of basically underlay, adding an underlay packet to do the overlay, or it can be done by a different, like by, for example, by the router that's receiving a packet and the router is adding the underlay as well. Is that the intent?
I'm sorry, I can't hear you clearly.
Oh, my audio is not good?
For now, yes.
Okay. So I was asking whether you're intending this to be done by as a part of overlay networking. So if a device is emitting the Rocky V2 packet, and then something is adding overlay, and that's computing the flow label, or is that for the very initial origin of the very initial process that creates the packet itself? So is it for the overlay, or is it for the initial process, or is it for both?
I think it's for both.
May I just I suggest we take it maybe offline just for the sake of time, and it looks like multiple people are confused about what device actually does this. So as I said, it would be, I would suggest you post a new version clarifying this to unconfuse all of us, and then we can discuss the next steps.
Okay, thank you.
Thank you.
Got it.
Okay, so now we're going to talk about ICMP. I'm getting slides up. Slide clicker. Sorry, too many. Okay, hold on. Okay, slide control.
Thank you. My name is Balázs Varga from Ericsson, and I would like to present on behalf of the authors this ICMP error handling draft. There are reasons why there are two drafts on this. So unfortunately, we think that on the SRv6 VPN scenarios, if we are looking to the observability, there are lacking capabilities. And the two drafts that will be presented are focusing on these scenarios in order to fill those gaps. There is a different focus in the two drafts. The draft I will speak here about is about how to find the location if you have a failure in the SRv6 network, which prohibits the connectivity over the VPN network. And the intent is to provide transport network visibility to the VPN endpoints by the ping and trace route. Regarding the solution, we just intend to provide a basic tool in order to cope with such situation. And in our draft, it is out of scope to cover complex scenarios where you have multiple technologies, where you are using multiple encapsulation in the SRv6 network. If we are looking to a VPN environment, the challenge, if you would like to provide detailed information about the path, is that the P nodes are not VPN aware. So they don't know where to route the ICMP error messages, which are VPN specific. Furthermore, P nodes can be also IPv6 only. So if you are providing VPNs with IPv4, IPv6, the P nodes, if they are IPv6 only, of course, they will not be able to generate ICMP error messages for IPv4 endpoints. The essence of the solution is that let's focus on the error-free part of the connectivity, and let's use that in order to provide the feedback for the endpoints. So the ingress PE, this is here we have defined an updated encapsulation that is affected the source IP address that is used for the encapsulation in order to be VPN specific. And when the ICMP error message is received back, then the ICMP processing function on this ingress age node, this is also something we propose to change. The P nodes inside the network, they are service unaware and they are doing the standard RFC 4443 operation. So there are no changes on the P nodes. And we are also not involving the egress PE node. We are trying to find issues towards the ingress PE node. So that is the primary reason why we don't want it to involve those nodes in the ICMP error handling. This slide is just summarizing who is doing that, who is doing what if a packet is transported over the network. The ingress PE node, it will do a VPN packet encapsulation according to the uniform model, and it will add this VPN specific information in the source IP address. The P nodes are just doing the standard ICMP error operation. There are no changes here at all. And the ingress P will receive the ICMP error message, and it will process it and make it forwarding according to the VPN based on the information that is already in that packet. So we are proposing an updated ICMP error message processing on the ingress node, and a method to modify and forward the ICMP error messages in a VPN specific way to the endpoints inside the VPN. The current version is version 02. There were some editorial changes, and from the technical perspective, the main item that we have changed is to adding reference to section 8 of RFC 2473, which is dealing with the IPv6 tunnel error reporting and processing. And the text was also highlighted where are deviations from this RFC. This is where we think definitely some further work will be needed. We have received a lot of comments on the list, both in the 6-man and the spring list. So many thanks for that. And this is what we intend to have as a next step as well. So further feedbacks are very welcome, especially regarding the VPN failure scenarios we intend to cover here and the expected behavior. And just in the note, I have also pointed to Zafar's draft, which is focusing on a somewhat different problem statement, how to check the path over the network. And that's it, practically.
Okay, cool. So as I said, maybe unless there are clarifying questions just for this draft, right, we can hear the second presentation and then talk about, because I personally have few comments which relates to both of them. So yeah, so Zafar, okay, clicker, slides.
Thank you.
Yeah, hold on. Okay, and clicker.
So this is the draft that we started and implemented for ICMP error handling, and thanks for setting the stage. While the board draft talks about or handle the same base, which is the ICMP error in SRv6 VPN, the use case is slightly different. So just highlight that there's one more thing is that there is a 6-man, says a spring presentation that we're going to do joint, and we have discussed and agreed to merge the drafts and then produce one draft and forward that, because these are complementary procedures. So from a problem statement point of view, the context is really SRv6 VPN. So if you have in this draft, what we the previous draft that we talked about is about the trace route and finding where the problem is. But this draft is more generalized in the sense that if you have a packet that was originally delivered as C1 and the context is SRVC's VPN, and there is an ICMP error. For example, the ICMP error could be the path, the MTU value exceeded, and then you have to send that packet back to C1. So this is a generic solution to that problem. But obviously, the assumption is that this is a VPN context, and the provider is willing to share that information with the customer. So that's the underlying assumption, obviously. Otherwise, these packets, these ICMP errors that are generated in the core are not to be supposed to be delivered to the customer device. So that's the base assumption to start with. The Cs may be IPv6 or IPv4 cable, but the most important point here to note that in the network, in the VPN scenarios, the context, the VPN information, how to forward that packet back to the source CE or the CE is available only at the PE nodes and is not in the middle of the network. So P node doesn't know how to forward that packet. P node just know to either send it packet to a PE node that can forward that packet towards the CE. The P node doesn't have that information. So for this draft, the approach taken is take the same approach, same problem, same solution. MPLS has the same, MPLS VPN has the same problem, is that if you have an ICMP error and you are allowed to send it to the customer device, then you will, from the P node where the error happens, because P node doesn't know how to forward, but it actually let the packet go forward towards the egress PE, who knows how to send that packet back to the invoking CE. So that is the same notion that is extended here in this draft, that the P node can actually let the packet go, which exceed the thing, let the packet or the part of the packet go towards the egress PE, who can actually then send it to the invoking CE. And that's really is the core of this. So you don't need a VPN context at the invoking or at the ingress PE or egress PE. There's no changes required at any of the PE sites. There's only changes required at the P node to be able to let the packet forward towards. Okay, so and the rest information from the egress PE as well as on the ingress PE is really their forwarding information. Their regular VPN forwarding, everything else happened in the data plane, and I explain it further. So I use an example, which is a trace route example, is easier to comprehend to illustrate the solution, but it is applicable to any ICMP error. It's not limited to trace route. So let's take an example. A CE1 created a trace route probe with a hop limit of 2. And that's the packet. Looks like it is a trace route from CE1 to CE2. When it comes to the ingress PE applies the regular IP SRVC's encapsulation to this packet, which is what is highlighted in a red box, and which is actually to say that this packet to go to PE2 VPN SID. That is the encapsulation that is applied. And the only thing that happened to the customer packet is that the hop limit got decreased to that packet because it's a uniform model. So the hop limit got copied from the incoming packet to the provider header. Okay. So in this case, this packet will have an ICMP exception at P1. And P1 is the device that needs to create an ICMP error for the CE1. So what it needs to happen is that this error, which is the lower packet, focus on the lower packet with a box in it. This is P1 telling that there is an ICMP error and it needs to go to CE1. But because P1 doesn't know how to forward, it puts in the original VPN SID where the packet was going towards. So it copies that PE2 VPN SID in the outer DA. So from then on, this packet goes regular forwarding towards the PE2. PE2 also do the forwarding lookup on this packet like any other packet, and it finds out that it needs to go to CE1, and it has forwarding information how to forward. So it's normal VPN SID processing, and the packet goes through the data path towards the CE1. So essentially, the MPLS does, in MPLS, we do the exact same thing. So same operational experience for the service provider. And there are, yeah. So the main point to note here is that the only node that needs change is the P node, which, because it cannot forward the packet towards the CE, it uses the incoming packet destination or VPN SID to complete the rest of the forwarding. Okay, so yeah, this is fine. I think the main next step is really we're co-presenting these drafts in the spring, and we will merge because the things are complementary. Here we are trying to find out if the data path is intact. How do we use the data path to send the packet or probe or packet ICMP error towards the CE? And in the other draft is like more like finding if there is brokerage in the data package further. Yeah. So now I think it would be a good time to ask for any questions, comments.
Yeah, I have questions about specifically your draft before we go into discuss the whole ICMP processing stuff. First of all, clarifying question, did I get it right that P router will be spoofing the source address in this case, in the outer header? The source address of this packet, which it sends towards P2, will be actually not P1 source address, but PE1 address. Is it like some source address spoofing happening here?
No, so the source address, if you look at the packet that is in front of you, a source address is actually it is the P1 source address. It's not PE1. It's the P1 source address because he's the one sending. Is the destination address that he uses from the packet. This point we can clarify. The source address is its local source address, because if this packet happen to have another ICMP error, you really want it to be intercepted by P1.
Because I don't think it's what your slide said, and it's not what the draft says. It says that source SA is PE1, right?
Yeah, so I think this is what we need to fix. The SA is P1. There's no reason to move to use this is a fix that we do in the next revision, because there's no reason for it to pick somebody else's address. It is his address, because if there's a further ICMP error, we want it to get to P1, not PE1.
Yes, okay, so in quick, I know time is over, but quick question. If I understand correctly, you're looking through the whole packet to find the most inner header, right? At some point of time. What happened if C1 already sent you a tunneled packet, which already had IP and IP encapsulation? Would it cause any problem or not?
No, it would not cause any problem. And in fact, draft does cover that and talks about it. Let's say, for instance, you have an FRR and the packet has another FRR header. The way that the packet processing happens is from the packet, which is where you need to send the payload. From payload to the packet, which is the gray packet here, the header of that packet. And if that, based on that address, is the decision is made in terms of where to pick up the PE2 where the packet can be forwarded. So it's the last SID after that. So it picks up happen. So if there are other headers ahead of it, they are not looked in.
Okay, thank you. Ron, is it like clarifying question for this draft specifically?
Yes.
Okay, quick.
Okay. It seems that this strategy is applicable to any kind of IP and IP tunnel. IPv4 over IPv6, IPv6 over IPv4, GRE, you name it. Why is the scope limited to SRv6?
So Ron, we did talk about this and you suggested the generalization draft as well. We are happy to have the generalization draft progress. But here, the implementer that wrote this draft were doing it for a customer that had this problem and we solved it together and your company is involved in this. HP did the implementation. It'd be good to have this SRv6 specific because then it also gives implementer a view on how to implement this procedure and all for SRv6 only. There could separately be a separate draft in area about generalization and this way of doing it because MPLS did it. It is totally applicable to other tunneling technology.
If the generic draft is specific enough, why does this one need to exist? The need for its existence points to a problem in the generic one.
No, I think this needs to exist because this does explain clearly for an implementer how to do it. Because I asked the same question to you when you wrote the draft. I don't know how UDP tunneling work, and you need to explain to me packet by packet how it will work. Maybe then down the road, you wrote that draft and it's so abstract that nobody else can implement it because implementer needs these kind of level of details.
And let's fix the generic draft.
And I'll be honest with you, Les, if you ask me, if you give me generic draft and ask me to implement for other tunneling, I don't know. I mean, I need some reference and what to do, what is going on, detail. I think this draft and what we talked about with the other draft, they stand on their own. If there is a generic draft that we write, we are happy to collaborate on that and all, but both can go. This is the ships in the night.
Okay, so now I think we might want to talk about both drafts in general, and I have a question for authors of both drafts, right? First of all, I'm a bit confused about how it is supposed to work when you have two ways to process the same ICMP. Is it going to be configurable, one of the 14 competence way to process ICMP we're going to use on a given network and leave it to operator, or how do you guys see it working?
So the implementation, this is really, there are two things here, right? The node where you have this ICMP error is really depends on that local decision on that node or local implementation. Let's say if you have a classic node that has not implemented, is there a node which is a brown node has not implemented this procedure which is in draft early, then it will then what was in the other draft, it will be the ICMP error will be sent back to this PE1 and the PE1 will process and the other draft become important to use, and we will in the next revision we will clarify, but in this revision it's very clear what is the policies and how these are picked up. So we will further clarify those policies, but I'll let Varga talk.
Yeah, so there are differences in the encapsulation. In our draft on the ingress PE, we have modified the source address. And based on the source address, if you know the SRv6 structure, and you are a SRv6 node, so you should know that structure, you will be able to identify whether a VPN-specific seed is in the source address or not. If not, then this method can be used. If it is there, then you can use the other method. So that is an easy way to decide locally on the received packet if the hop limit expire, how to behave. So this is what Zafar mentioned, that these are ships in the night from that perspective, that you can make distinguish what type of packet you have received.
I'm just wondering if this needs to be somehow documented and they, like, it could be actually kind of generic document saying this is how you process ICMP, and it could be two paths which you take in based on something, right? Because for unprepared reader, this looks very conflicting, right? And interaction between those two, I think, needs to be somehow documented.
I fully agree. So on merging the two drafts, there is a lot of work to do. One of is definitely that.
Yeah, thank you.
One quick question, like this would be happening on P1, right? That means P1 needs to be aware of SRv6, which the whole point, a big part of SRv6 is that middle nodes don't. So
Yeah,
I don't see this working.
Yeah, so I think this is where things, this draft and along with the draft Valhar is also takes care of the cases when the P node is not SRv6 aware. Okay, so in those cases, the ICMP error always go to the ingress PE. So that's why we are covering all the cases. This is one case. The other case is when you have a node which is not SRv6 capable and is a node which is already deployed, and all it does, it push the invoking packet, copy the invoking packet and the ICMP error to the ingress PE. And in that case, the ingress PE does the processing of sending this packet back to the CE. And so these all three cases are there. This case is already there in the draft that you talked about, in our draft as well, in other draft as well. And we are going to make sure that, I mean, this is like two different ways of doing the solution when you have capability versus not capability. But we address both cases.
Okay, should we settle on one and just do one?
The thing is this, that it depends, there are advantages and disadvantages, and this gets into the weeds of the detail, that not in all cases one method works, because you have to put in, I mean, let's say for instance, we take the other draft, you have to put in a source address, which actually act as a hint on which VRF the packet belongs to. So you can actually look at the ingress PE and then look up for that packet on how to forward. In the other methodology, we rely on the existing forwarding table, not putting a special source address. So there are pros and cons. That's why it's not one size fit all. There are pros and cons. So it's the implementation choice. Thank you.
So everything is responsibility. I love the capture. They don't say ingress PE, they say English PE, because I think they are French PE, American PE, Chinese PE, and so on. Anyway, those two drafts are presented here at 6 man, but the arguments are here in the queue are basically related to Spring. So I know I'm looking at you, Joel. Should those drafts be done in Spring rather? At least they will need consultation between the two working groups for sure, right?
It is not accident that there is a presentation scheduled in Spring, and specifically that Spring is the one that asked that the authors merge. Now, I didn't because I'm recused for obvious reasons. But yes, the Spring chairs would like to see one draft, and then we will determine whether there's interest, but the protocol changes, whichever set of protocol changes, have to be done here once Spring has agreed on what approach we want to document. But Spring can't make the protocol changes. We don't own that. But the philosophy and approach we can agree on in Spring, so that six man doesn't have to spin their wheels waiting for us to know what we're doing.
So just to be clear, the Spring Charter prevents protocol modification, that's correct? Yeah. Okay, understood.
So, I
clarify.
think there is one thing that I'd like to mention is that there is no protocol extension to this, but I'll let, yeah.
Yeah, so yeah, I was like to ask, I don't even see this as actually a protocol change, because we're talking about a router behavior, which is kind of gray area. I do not think we're changing any bits in the protocols, right? We're doing some ICMP processing on device, which in the worst case scenario could go to int area, but I do not see how it changes IPv6 as a protocol. So I kind of sitting on the fence here, but however we classify this, I feel like it's a bit too early to talk in 6 months about this, right? So I think Spring needs to decide how you want the routers to behave, and then we can talk which working group specifies how SRv6 routers process ICMP.
So Joel Halpern again as SAVNet, as Spring co-chair, but also as a co-author on the draft, so I've got both sides and get myself confused. I agree with you that Spring needs to deal with it first, no problem. Whether this is a protocol change or a behavior change, and therefore whether it belongs in 6-man or int area, we're all good at working that one out. We can sort it out. I don't think SAVNet can, Spring can mandate that the behavioral changes that either draft need on its own, but the philosophy and approach to how it works for segment routing, Spring can take care of first, and then we'll bring it somewhere.
Beautiful. Thank you very much. You want to say something? Thank you. Okay, thank you. This concludes the session. We're almost perfectly on time. Thank you very much. And see you in November.
In San Francisco.